garden paving slabs measure 40 centimeters by 20 centimeters. That's each of these slabs here. So it's 40 centimeters long, 20 centimeters wide. The slabs are to be arranged to form a rectangular paved area. There are X slabs along one side and Y slabs along an adjacent side as shown. Write the length of the perimeter in centimeters in terms of X and Y. So let's look at this slab in the top left corner. This distance here is 40 centimeters and this distance here is 20 centimeters. So the slabs are 40 by 20. Each slab is rectangular. We have Y slabs down here. So what's the length of this side here of the garden? We just multiply 20 by Y. So we have Y times 20 or 20Y. So that's the length of this side here. What about the length of this other side of the rectangular garden? Well, each slab has a length of 40 and there are X of them across here. So we have X times 40 or 40X centimeters is the length of this side of the garden. How do we get the perimeter? Well, the perimeter is the distance all around. Well, we have two sides of length 20y, so we have 2 times 20y plus two sides of length 40x. So 2 times 20 is 40, so we have 40y plus 2 times 40 is 80. 40y plus 80x is the perimeter of this garden. The perimeter being used for edging means, the material being used for edging means that the perimeter is to be 64 meters. Find y in terms of x. So the perimeter is 40y plus 80x. Now, the perimeter is actually in centimeters because the sides of each slab are given in centimeters. See, it's 40 by 20. So when I wrote down the perimeter here, I have it written down in centimeters because we multiplied y by 20 centimeters to get this side and x by 40 centimeters to get this side. So we will be interested in getting the perimeter in meters because we want to equate the perimeter to 64 meters. Well, we could actually convert meters to centimeters. That's probably easier. So 64 meters is how many centimeters? Well, there are 100 centimeters in a meter. So 64 meters is 64 times 100, or 6400 centimeters. Now we're using the correct units, since this here is in centimeters. We have to find y in terms of x. Well, we could actually simplify this equation a bit by dividing everything by 4. Actually, we can divide everything by 40. So dividing 40y by 40 gives us y. 80 divided by 40 is 2. 6400 divided by 40 is 160. So y equals 160 minus 2x. So now we have written y in terms of x. Find the value of x for which the paved area is as large as possible. So I've drawn the paved area over here. This side here is 40x. Now this side here is 20 times y. What I will do is write this side here in terms of x. Well, 20 times y is 20 multiplied by 160 minus 2x. So I want to write this side, which is 20y, in terms of x. So we reduce the number of variables from two variables, x and y, to just one variable, x. So we multiply 20 in here. 20 by 160 is 3200. 20 by minus 2x is minus 40x. So this side here, in terms of x, is 3200 minus 40x. Now we're interested in the area of this paved area. I'll call it A. So to get the area of a rectangle, we just multiply the two sides. So one side is 40x, and then I'll multiply by this here. Now this expression has two terms in it, so I put it in brackets. 3200 minus 40x. So multiplying 40x by 3200 gives 128,000x. 40x times minus 40x is minus 1600x squared. We have x times x coming in here, so we have x squared. Now we want the value of x that makes a maximum. So you can see that for different values of x, we're going to get different values of a. So which value of x makes a maximum? So this is a max-min problem, which we've covered before. The way we do this type of problem is to look at the derivative of this function, dA dx. We know that at a max or a min, a local max or a min as it's called, the derivative is equal to 0. I've explained that several times before. If we look at the graph of this function, then at a max, a local max or a local minimum point, the tangent to the graph is horizontal, which means that the derivative, which is the slope of the tangent, is 0. Actually, you don't need to graph this, but if you do, you will see that it's in an inverted parabola because of the x squared term. This is a quadratic function. The x squared term is negative, so it's an inverted parabola. It actually crosses the y-axis at 0 because the constant term here is 0. We have an x term, an x squared term, and the constant term doesn't appear. There is no constant term, so that's so it's 0. Anyway, this is a rough graph of a against x. You don't really need to draw this, but just to remind you of why we put the derivative equal to 0, we can see that at a local max, the tangent is horizontal, which means its slope is 0. So the slope of this line is 0. So by putting dA dx equal to 0 and solving, we can find the value of x that gives a maximum value for the area, and that's the answer to the question. So we just have to solve this equation here. So the slope of this tangent is dA dx, and that's equal to 0. So differentiating this function here, if we differentiate 128,000x with respect to x, we just get 128,000. The x just drops out. When we differentiate this term, we multiply 2 by 1600 to give minus 3200, and we take 1 from the power, so we get minus 3200x. So we put that equal to 0 then, as I just said. We solve this. So solving this, we have to take 128,000 and divide by 3,200. That gives us 40. What are the units of this number? Well, if we go back to the question, x is just a number. It's just the number of slabs that fit along here, along this side of the paved area. So it doesn't have any units. Well, if you like, you could just write down 40 slabs. Find the number of slabs needed to pave this maximum area. Well, we know that x equals 40 gives the maximum area. So if we want to find the maximum area, we plug 40 into this expression here. If you think back to the graph, which I'll just draw again, the graph actually looks like this. Then we know that when x is 40, we have a maximum value for a. So what we're doing is now finding the value of a that corresponds to x equals 40. That's what we're going to do now. And from this maximum area, we can work out the number of slabs needed to cover the maximum area. So we just plug 40 into this expression. So for x, we write 40. In here we have 3,200 minus 40 times x, so we plug 40 in for x. Calculating all this, we get 2,560,000 centimeters squared, because this is an area, and we saw earlier that all the units were in centimeters, or the sides are in centimeters. So when you multiply the sides together, we get an area in centimeters squared. Now here I've written down the maximum possible paved area. It is 2,560,000 centimeters squared. Now, what about each tile that makes up that area? Well, we know that each tile has dimensions 40 by 20. The long side is 40, the short side is 20 centimeters. So what we can do is get the area of just one tile and then divide into this number to see how many of these tiles fit into this paved area. So how do we get the area of this tile? Well, it's a rectangle. We multiply 20 by 40. So the area of this tile is 800 centimeters squared. So when we do that, when we divide the area, the paved area, by the area of one slab, both units are in centimeters squared. So the centimeters squared effectively cancel, so we get a number that doesn't have any units. This is the number of slabs required, 3,200. There is another way that we can answer this question. We know that X slabs fit across the paved area and Y slabs fit down this paved area. So the total number of slabs required to cover this paved area is actually X multiplied by Y. So we have Y rows, if you like, of X slabs. So the rows are going across and we have Y of them. And each row contains X slabs, so it makes sense to multiply Y by X or X by Y. So that gives us the number of slabs. We know what X is. X is 40. Now, but what about Y? Well, we already have Y from a previous question, because remember the perimeter was constrained to be 64 meters or 6,400 centimeters. So we have Y in terms of X. So we multiply 40 by this expression here, 160 minus 2 times X, but X is 40. Calculating this, we get 40 times 80, so again we get 3,200 slabs.